Okay, so let's have a look at this test one. Okay, so with question one, for my question one, um, it was asked an intersection question. You could have been asked a union question. So it was randomly generated, this test. So intersection means you're looking for stuff that's in both sets. And so I look at one, it's not in both sets. I look at two, it is not in both sets. I look at four, and it's not in both sets. And I look at seven, and it's not contained in both sets. So there's not going to be anything that's contained in both sets. And so we're going to have the null set be the answer for that one. And if this had been a union question instead of an intersection question, then you put both of these together into one set, but you can't have any repetitions. So if there are repetitions, you have to eliminate one of them. And there aren't any repetitions. The only thing that would be different is it would put it in a different order, which, so 1, 2, and then 3, and then 4, 5, 6, 7, and 8. Okay, so that would have been the union if the question had been union. It wasn't the question was intersection, and these didn't have any. Now, in the test bank, that wasn't always the case. Okay, if I wanted to know what the intersection was, you're looking for stuff that's in both sets. So 2 is in the intersection. 1's not in both, 4 is not in both, and 7 is in the intersection. So to be in the intersection, it has to be in both. Okay, so again, it was all randomly generated, so hopefully that's enough to where you can see what your correct answer was once you see the solutions. If you don't, you're going to need to email me and we can get it sorted out. Okay, so here we are adding. We're adding. If you're adding, you can just drop the parentheses. First of all, there's nothing outside the front parentheses, so I can just drop that, drop the parentheses. And then we're adding, and there's nothing out the front there, so I can just drop those. Now, these are written from largest power of x to smallest power of x. So the largest power of x is x to the fourth. So let's gather up all the x to the fourth terms. So 8x to the fourth plus 2x to the fourth is going to be 10x to the fourth. And then now the next largest power is going to be x cubed, or x to the third. And so 5x cubed plus 5x cubed is going to be 10x cubed. Now, already from the selections, it's going to have to be this one, just from multiple choice selection. But let's continue. Do I have any x squared terms? Yes, I do. There's an x squared term, and there's an x squared term. So negative 6x squared plus 9x squared is going to be 3x squared. And then I've got 9 and plus 4 left. And that is matching what's written here. Okay. All right, let's continue. Now we are subtracting. The front set of parentheses doesn't have anything in front of them. I can drop those, but now I have a minus sign out the front here. It has to be applied to every term inside the parentheses. So I'm going to have minus 2x to the fifth And then I'm going to have minus negative 16x to the fourth, and that's going to give me positive 16x to the fourth. And now if I do this from biggest power of x, the fifth power comes first. So 7x to the fifth minus 2x to the fifth is going to be 5x to the fifth. And then for my x to the fourth, I'm going to have negative 10x to the fourth plus 16x to the fourth, and that's going to be plus 6x to the fourth, which is going to be this one here. Now, if you did not distribute your negative sign, if you did not apply it to everything inside the parentheses, then instead of getting positive 6x to the fourth, you would have gotten a negative there. And then when you added the two negatives, you would have gotten negative 26. That's that bogus one there. And that is not correct. So when a minus sign is out the front of parentheses, it has to be applied to everything inside. Okay, so let me continue. We are still subtracting. I don't have anything out the front here. So I can just drop the parentheses and copy as it is. But I have a minus sign here, and it must be applied to everything inside one by one. So I'm going to have minus 8r to the fourth. Then I'm going to have minus negative 9r cubed, which is going to be plus 9r cubed. Then I'm going to have minus 6r squared. And I'm going to have minus negative 2r, which is going to make that plus 2r. Now I'm going to gather like terms. So my highest power of r is r to the fourth. So I've got an r to the fourth term there. And I've got an r to the fourth term there. Negative 2r to the fourth minus 8r to the fourth is minus 10r to the fourth. And so already looking at these selections, that's the only one that it can be, because none of the others have a negative 10r to the fourth. But let's continue. Then my next power is r cubed. So 9r cubed plus 9r cubed is going to be 18r cubed. And then I need to find the r squared terms. I only have one, so minus 6r squared. And then I've got minus 3r plus 2r, which is going to be minus 1r, which is just minus r. And so that's matching up with that one there. Okay, all right. Let me go on to the next. Okay, so let's multiply these. So we're going to FOIL these. And if we're going to FOIL these, I'll do those two first. And then I'll do these two. Okay, so in black, I'm going to have x times x, which is x squared. Then I'm going to have x times 9y. And if you have x times 9y, that's a product, but you want to write products with the number out the front and then the letters in alphabetical order. So x times 9y, I'm going to write as 9xy. Then I'm going to do the blue bit, 8y times x. Again, that's just a straight product. You want the number out the front, but you want the letters in alphabetical order. And then 8y times 9y. Well, 8 times 9 is 72. And y times y is y squared. Okay, now I'm just going to write this all in one color. So I only have one x squared term. But then you can see I have two xy terms. So 9xy plus 8xy is 17xy. 9 plus 8 is 17. So 9xy plus 8xy is 17xy, and then plus 72y squared. Now you have to be really careful here. Like, this is not correct because it doesn't have an x squared and a y squared term. So I want x squared plus 17xy plus 72y squared. So this is looking to be the correct one. This is not correct because that should be a 72. This is not correct. That should be a 17. So you just got to be really careful when looking at those multiple choice selections. Okay, so that's what I think it is. Okay. All right, determine whether the relation represents a function. If it's a function, state the domain and range. This is not a function. And the reason it's not a function is because here we have the domain, here we have the range, and you're not allowed for something in the domain to be mapped to more than one thing. And Carl is in the domain, but he's mapped to more than one thing. So this is not a function. So I'll keep going. Now, if you're trying to determine whether or not the relation represents a function, then your domain is going to be the set of your first entries. And if you have any repeats in the domain, then you do not have a function. So my domain is going to be 41, 5, but then 5 is repeated. So this is not a function, because I have stuff in the domain that is repeated. Now, how would this look as a drawing for you to see that? So this, again, this one's not a function. Again, these were randomly generated, so your test might have one that is a function. If none of the first entries are repeated, then you have a function. But let's look at what this looks like. It is a relation. The domain, I'm going to have 41. I'm going to have 5. I have 5, it's repeated, but I'm not going to write it twice. I have 14, and then we have 30. Then in the range is the set of second entries, and those can be repeated, but they're not here. Okay, so what would this look like as a drawing? Well, 41 is mapped to -4. 5 is mapped to -3, but 5 is also mapped to 0. And so in the drawing, this violates our definition of what a function is, because we have something in the domain that is mapped to more than one thing. And so I wouldn't even need to continue any further. Okay, so that's not a function either. All right, now, how do you find a value for a function? Well, f of x is equal to y. So f evaluated at your x coordinate is equal to your y coordinate. So this is our definition for f of x. This is our y value. So let me make it a little bit bigger because it can be hard to see. Typing's a bit small on this one. Okay, so we want to evaluate f at 1. So let me write this bigger. So now I want to find f evaluated at 1. So everywhere there's an x in the formula, you're going to replace it with 1. So 1 squared is 1. And I'm just going to have 1 plus 2. And so that's going to give me -7 in the numerator. And it's going to give me +3 in the denominator. And -7 over 3 is the same as if the negative sign's out the front. So f of 1 is equal to negative 7/3. Now, if you were asked, if you were told that you have a function and this is true, then you can automatically get a point on the graph, because this will be the x-coordinate of your point, and this will be the y-coordinate of your point. So you weren't asked for that in this question, but the point 1 comma negative 7/3 is on the graph of f. But that's not specifically what this one asked for. It wanted f evaluated at 1. All right, now we want f evaluated at 4. So everywhere there's an x, I'm going to replace it with 4 in parentheses. So that's going to give me 16 plus 8 plus 4. That's going to give me 24. And 24 plus 4 is 28. Okay. So my answer is going to be 28. Okay. All right, now if you have a point on the graph of a function, so here's a set of points that are on the graph of f. What a function f does is it maps the x-coordinate into the y-coordinate. So f evaluated at the x-coordinate is equal to the y-coordinate. Now, we've been told to find f evaluated at 5. So you need to go through this set of points and find the point whose x-coordinate is 5. And there we have it. Now, what does f do? F maps the x-coordinate into the y-coordinate. So this means f, I meant to do that in black, f evaluated at the x-coordinate is equal to the y-coordinate. And this is our answer. The negative 3. Okay. All right, now what is the domain? And we need to write our answer in interval form. And do not type any blank spaces, because if you type a blank space, Canvas interprets it as a character and it won't match the answer. So no blank spaces. Okay, now we have a fraction, a rational expression, and the denominator is not allowed to be 0. So what's the denominator of this? 2x plus 10 is not allowed to be 0, but we need the restriction on x, not the restriction on 2x plus 10. So we need to rewrite this where x is by itself on the left-hand side. So I can add 10 to both sides. I can subtract 10 from both sides. And so this will become 2x is not equal to negative 10. 0 minus 10 is negative 10. And then I can divide both sides by 2. And if I divide both sides by 2, I get x is not equal to negative 5. Now, that's a correct answer, but it said write your answer in interval form, as you would in web work. So if x is not equal to negative 5, then on the number line, you want everything except negative 5. So if I read the number line off from left to right, then I'm coming in from negative infinity, coming up to, but not including negative 5. Then I got to jump over and then continue on past negative 5. And we don't have a infinity symbol, but it says in the instructions to type INF. So what I'm going to type without any spaces is going to be that. Okay, so that's what I'm going to type. All right, so parenthesis, negative infinity, comma, negative 5, parenthesis, union symbol, capital U, -5, comma, positive infinity. Okay, so that will be my answer. And there are no spaces. All right, we made sure that there were no spaces, no blank spaces. Yeah, I had one student that had a blank space on the end, and they just didn't know why the answer was counted wrong. Because when you look at the answer, it doesn't look like it's wrong, but you can't see that blank space on the end. So make sure there's no blank spaces in front or on the end there. Okay, so that's the answer to that one. All right, now, given this, what is the domain? Now we have f of x is a square root. And if you have a square root, and it's not in the denominator of a fraction, which it's not, if we have a square root, then what's inside the argument, so that's what is inside, has to be greater than or equal to 0. So our argument here is 13x plus 18. But now we have to get the restriction on x, not on 3x plus 18, so we have to rewrite that to where x is by itself. So I will have 3x is greater than or equal to 0 minus 18, which is negative 18. Then to get x by itself, I need to divide both sides by 3. And dividing by a positive does not change the arrow, the direction of the arrow. If you multiply or divide by a negative, it will flip the arrow. But I'm okay for that. And negative 18 divided by 3 is negative 6. So this is my domain. My x values are going to have to be greater than or equal to negative 6, but we need to write that in interval form. So on the number line, what does that look like? So let's just plot where negative 6 is, and I'm going to do it in red now. So x is greater than or equal to negative 6. We're going to start at, and we're going to include negative 6, and then we want everything to the right, so the arrow's pointing to the right. So what I've drawn there is the number line presentation of this, and once you have the number line presentation, you can get the interval notation from left to right. I start at and I include negative 6, and then I have everything forever. And now if I'm going to type that in, so if I'm going to type that in, instead of the infinity symbol, because I don't have it on my keyboard, I'm going to use inf, INF. So I want to type that in. Okay. So I must start with a square bracket, which is on my keyboard, then negative 6, comma, and then INF, and then a parenthesis. Okay, and no spaces. Okay. All right, now we have a square root, but it is in the denominator of a fraction. So if you have the square root that's in the denominator of a fraction, then the argument inside is strictly greater than 0. And our argument to here is 5x plus 20. And that must be strictly greater than 0. It's not allowed to be 0, because if it was allowed to be 0, you'd have 0 on the bottom, and we can't have that. So I have to rewrite this in terms of x. So I'm going to subtract 20 from both sides. And when I do that, I'm going to have 5x is strictly greater than 0 minus 20. And then divide both sides by 5. And I'm going to get x is strictly greater than negative 4. And on the number line, we would start at, but we would not include negative 4, and then everything to the right of it. And so in interval notation, reading this off from left to right, I'm starting at but not including negative 4, and then continuing forever. So over here, So over here, I need to write negative 4, but instead of the infinity symbol, which I don't have on my keyboard, I'm going to write INF. And we don't want any blank spaces. Okay, so no blank spaces, so I'm going to make sure. Okay, so I'm going to type that in now. so that one should be everything that's needed there. Okay, which of these graphs is not a function? Well, you have to do the vertical line test. And this graph here does not pass the vertical line test. We have a vertical line that is intersecting it more than once. So just from these two intersection points here, this one is not a function. Okay, so now with the labeling, and let me make this. Okay, so now with the labeling, we can see that D is not a function. Okay, now it would accept it if you put it in parentheses, and it also would have accepted it if you typed it as a lowercase d. So that one's not a function. The other ones all pass the vertical line test. So any vertical line that I care to draw, there's infinitely many, intersects it at most once. At most once. At most once. Okay, so those others pass the vertical line test. Let's keep going. All right, what is f evaluated at 3? And here's the graph of my function. So remember, if you have a point on the graph, then what a function does is it maps the x coordinate into the y coordinate. So if to get f evaluated at 3, you have to first find the point whose x coordinate is 3, because then f will map that point into the y coordinate, and the y coordinate will be the answer. So let's go over here to the graph, and you can see here from the grid 1, 2, 3, and if I come up here, this point here I can clearly see is the point 3, 6. Now this is really important. The answer is not 3, 6. It's not. And in your web work, if you had tried to answer with the point, it would have been wrong. To get f of 3, you first find this point, and what does f do? It maps the x coordinate into the y coordinate. So f evaluated at 3 is equal to 6, and the answer is 6, not the point 3, 6. That's an intermediate step. F evaluated at 3 is equal to 6. The answer is 6. And there's no way you would have gotten web work answers correct if you had given 3, 6 the point as your answer. Okay, that would not have happened. It would have been marked wrong, and you would have had to go back and adjust. Okay. All right. Okay, now what is f evaluated at 6? Okay. For this one. So first of all, I need to find the point with, so I want to find f evaluated at 6. Find the point with x coordinate equal to 6, if it exists. Because if you can find a point with x coordinate 6, f will map the x coordinate into the y coordinate, and the y coordinate will be the answer. If there is not a point with x coordinate 6, then it's not defined. Okay, now let's look at this graph. I need to find a point with x coordinate of 6. There is only one point on this graph with x coordinate of 6, and it's this point here. And this point here has coordinates 6, -1. That point, being hollow, is not there. So we do not have another point with x coordinate 6. There's only one point with x coordinate 6. So this point is on the graph. What does f do? It maps the x coordinate into the y coordinate. Therefore, f evaluated at 6 is equal to -1. All right, the answer is -1. Come here and I'm going to type in -1. Now, let's change the question. Suppose we had been asked what is f evaluated at 1. Well, you would have to first find the point on the graph with x coordinate equal to 1. And then f would map the x into the y, and that would be your answer. But when I look at this graph, there is not a point with x coordinate 1. There's not one. Nowhere on the graph. This is x equals 1, and see, this point is not here. It's hollowed out. So there does not exist a point with x coordinate. What happened here? Okay. With x coordinate 1. So if that had been the question, so I'm changing the question. If that had been the question, the answer would have been does not exist. Okay. And I think another one was, I'm changing the question. What is f evaluated at -3? You have to find the point whose x coordinate is -3. Then what f will do is map the x coordinate into the y coordinate, and the y coordinate is the answer. Now, if I come here, here's x equals -3, and there is only one point on that graph that has x coordinate -3. Here it is. It has coordinates -3, 1. So -3, 1 is on the graph. These points do not have an x coordinate of -3. See, they're hollowed out. They're not there. And so what f would do is map the x into the y. And so the answer would be 1. If that had been the question. But that's not the question. We've already answered the original question. But, you know, they were a test bank, so probably a third of you got the other two questions that I went through. Okay. Now, the question here is not, you have not been asked what is f evaluated at -3. You have not been asked that. And if that had been the question, it's hard to tell from this graph, but it looks like the answer would be around -16. But that's not the question you have been asked. Okay, so remember f of x is equal to y. So f of x is equal to, you need to find any points with y coordinate -3. And then see what the x coordinates are if you were to solve it. But it only asks you how many solutions there are to that. So I need to find, first of all, any points with a y coordinate of -3. So -3 is about here. Okay, you can see on this y scale 0 and -5. -3 is about there. That point has a y coordinate of -3. That point has a y coordinate of -3. So does that one. And so does that one. So if this is just a line, a horizontal line that's going through -3 on the y-axis, I would actually have 4 different solutions to this, f of x equals -3. And the solutions would be whatever their x values are. But you weren't asked for the specific solutions. You were asked how many solutions are there. And there would be 4 solutions. And I had it to where if you typed the number, if you typed 4 out as a word, you would have gotten full credit, or if you just put in the number 4. There are 4 solutions to that. And you were not asked to work out what they were. You were just asked how many solutions are there. Okay. Now, suppose you're told that you have a function and that f of 2 is equal to 11. Well, again, you see this enough times and eventually you'll remember it. F evaluated at the x coordinate is equal to the y coordinate. And so if f of 2 is equal to 11, then my point has x coordinate 2 and y coordinate 11. Okay, so the answer to this specific question is the point 2, 11, no spaces. Okay. And you can check it. What does a function do? It maps the x coordinate into the y coordinate. So f evaluated at 2 is equal to 11, which is what we were given in the first place. Okay. All right. So if you remember the rules, they're not difficult questions. There are a lot of rules to remember, but that's just part and parcel of a math course. You have to remember those rules. Okay, and we're almost done. Okay, find the domain of f. So for domain, I'm going to use the x-axis to measure how wide. From left to right and leave out any gaps. Left to right, leave out gaps. Okay, so I'm going to start here. That's the leftmost point. That point is not contained. So I'm going to start there, and I'm not going to have that. But that's where I'm going to start. And then if I'm using the x-axis like a tape measure to measure how wide this is, it comes over to -2, and -2 is contained. So I'm going to color that in. Okay, so again, I'm starting at -6 there and ending at -2. Then there's a gap. If you look up or down, there's nothing until I get to 1. And so now I'm going to pick it up. 1, I have an x coordinate of 1, so 1 is contained on this graph, so I'm going to contain 1. I'm going to fill it in. And using the x-axis to measure how wide this second part is. And I keep going until we get to 5, and 5 is contained. All right, so what I've drawn in blue is the domain. You have to give your answer in interval form. So you're going to need to read this off from left to right. So if the blue. So I'm starting at, but not including -6. Then we continue until we get to -2, and -2 is included. So we have a square bracket. Then there's a gap. And we pick it up again at 1. And it's solid, no gaps, and we end at 5 on the x-axis, and the 5 is included. So we have a square bracket. So this is what I'm going to want to type in. Okay, so let me move this down. And I'm going to type in parenthesis -6, comma, -2, square bracket, capital U, square bracket, 1, comma, 5, square bracket. Okay, and no spaces. Okay, so I'm happy with that. And then finally, what is the range? Well, with the range, you use the y-axis to measure how tall from bottom to top. And how do you know if something's included or not? Well, this does have a bottom. I'm going to start here at -6, like that. Now, as I move up, if you can see a point on the graph, either to the left or to the right, then you don't have a gap. So I can see points to the right. When I get here, I can actually see points to the both right and left, but that's fine. And then once I get past here, I can see points just to the right again. And then that stops up here at 6. And we can see that this is included. So I'm including that. Now you must read it from bottom to top. So I'm starting at and including -6 and unbroken all the way up to +6. And we have inclusion, and so we have square brackets. Okay, so I'm going to submit that. And If I didn't make 100, we will see where I made a mistake, blah, blah, blah. Okay, my score is 100 out of 100, so I didn't make a mistake. So if you have any questions about your test, then please email me and we'll get it sorted out. So I'm going to stop this video.